if we taking off from where we left on the whiteboard, the function will read like this. The first line will be func prot theta, as you have always done. This is to protect the function. And then we will have CLF, that means you clear the graphical screen. And then we have a few more lines, and just before the line, on each line, we have put 2 slashes, right inclined slashes, which means that the computer doesn't get the message. Those messages are for you, for the examiner. So in the first line, I write Fermi-Dirac distribution because you're dealing with this. And then I write n is equal to exponential e minus u k into t plus 1 minus 1, which is the formula that we have seen earlier. That means formula number 2. I write the Boltzmann constant in electron volt per Kelvin. And I also take a value of mu. I don't specify the element. I just say that it is 7 eV, electron volt. So you can see that epsilon, mu by kT becomes a pure number. From the units itself, you can make that out. And then what follows is what I had already written on the whiteboard. That means function n is equal to Fermi 1z, etc. N function, then z I have taken as 0.01, etc. And then I go up till Fermi 5. Every time I increase the value of mu by kT, it goes from 1, then 2, 10, 100, and 1000. All right? So the higher the value of mu by kT, lower is the temperature. So when the last one, Fermi 5z, where I write Fermi 5z, I have taken mu by kT is equal to 1000. So this is the nearest value to 0. Not exactly 0, but very, very near to the value. A little less is 100, and so on and so forth. And on the whiteboard, I had shown just plot Fermi 1, Fermi 2. Here, I have gone up till Fermi 5. So it's just for 5 temperatures. And the rest of the things, as I mentioned before, it is the same: X title, X label, Y label, HL, legend. Legend is what you get on the right-hand side of the graph. Now, after having written this, I go to, you can have a look here, I go to save and execute. I do that. I've already done that, in fact, saved and executed. And then you will see the graph that has come. And I'll take it a little further, and you can see the graph that it has come. It is very much similar to the expected graph that I had drawn earlier on the whiteboard. This red line which I have drawn, that is the one which is closest to 0. The black one is a little less than 0, and so on and so forth. And the red one has the highest temperature. So this is how you have to draw the graph. And you can see that you have got the legend on the right hand side of the graph. The x and y axis are labeled, and there is also a title to the graph. So one thing I would like to tell you over here, that if I change the value of z, that means if instead of 0.01 I take some other value, let us say I just take 0.1. Okay, I've changed it to z is equal to 0, the interval is 0.1 and 2.0, and then of course again I go to save and execute. Then the graph changes slightly, because this gives you the red graph, but it is superimposed on the black dots. So this is not so clear, where in the earlier graph red and black dots had come differently, but here it is overlapping. So by changing the interval, you can get better graphs, and it depends on you. One thing I would like to tell you, you must have studied that in the graphs, all for whatever temperature, when epsilon is equal to mu, that means epsilon by mu is equal to 1, all the graphs will pass through 0.5. That means the mean occupation number has to be 0.5, whatever be the temperature at epsilon equal to mu. If you look at equation 1, if epsilon is equal to mu, then E becomes, the exponential term becomes e to the power 0 by kT. So whatever be the temperature, that becomes equal to 1. So 1 by 1 plus 1, that means it is equal to half, and that is what is represented over here. And for whatever be the temperature, all graphs have to pass through 1. So just try this out. If there are any problems, you can ask me on WhatsApp, and then we can go ahead further. Once you have understood this, plotting similar for Bose-Einstein statistics will be just child's play. Once you do this, there will be no problem. So happy plotting time, and get back to me on your WhatsApp.